Now let's understand the forces which are applied on a block which is lying on an inclined plane and what is its acceleration. Let's say this is an inclined plane, this is inclined. This is an inclined plane at an angle theta with the horizontal, and there is a block of mass m which is over here, it has been released. For all the surfaces they are frictionless. So if we draw the force diagram of this, so there are two forces which are acting on the body. One is mg which is acting this way, and the second is normal reaction. Normal means perpendicular to the interface. This is at an angle of 90 degree. This body will apply a force, normal reaction onto this n, and this will react. To every action there is equal and opposite reaction. Similarly, when the earth applies a force mg on it, this will also apply a force mg onto the earth in the upward direction. We are not bothered about the earth, we are just bothered about the block, so we have drawn the forces on the block. So onto the block there's two forces, one is n acting this way, the other is mg acting this way. We have taken this as x-axis, this is y-axis, that is motion, because the motion is going to this way, so we take this as x-axis, this is y-axis, this is x-axis, this is y-axis. When the block will moving this way, it shall be coming like slipping like this, sliding like this, exiting like this, so it will not be jumping along the y-axis. So there is net force, there is no net acceleration along the y-axis. When there is no acceleration along the y-axis, it means the net force along y-axis is equal to 0. There is no net force along the y-axis. Had there been any force along the y-axis, it would have moved this way or this way. Along the y-axis, it would have been hopping. But this is not happening. This is very smoothly, without the change of y coordinate, it is going in this direction. It means the velocity along the y-axis is not changing. Acceleration along the y-axis is equal to 0. So net force along y-axis is equal to 0. So now what we do is, we break this mg. This is along the y-axis. We break this force mg in its rectangular components. One is this mg sine theta, the other is mg cos theta. We see that this angle is theta and this angle is obviously 90 degree. This is a right angle triangle. If this is 90, so this is 90 minus theta. So this is 90 minus theta. This and this is 90, so this comes out with theta. We know, that is what we have done earlier also, resolution of vectors. If this is a force, this is theta, so this comes out to be cos component. If this is mg, this comes out to be mg cos theta, and the other rectangular component comes out to be mg sin theta. Also, let's say, if you wish to remember, so whatsoever is the angle between the two lines, intersecting lines, the same will be the angle between their perpendicular lines. To this line, perpendicular to this line is this line. Perpendicular to this line is this line. This is 90 at an angle of 90 degree normal. This is at an angle of 90 degree. So perpendicular to this is this, perpendicular to this is this. So whatsoever is the angle between these two, the same angle has to be between these two. So this is mg cos theta, and this is mg sin theta. Because this is not moving along the y-axis, it means net force, summation of force along y-axis is equal to 0. It means n is going to be equal to mg cos theta. But there is an unbalanced force which is along the x-axis. What is the unbalanced force along this way? That is Fx, force along x-axis, is equal to mass into acceleration along x-axis. The force along x-axis is responsible for acceleration of the body along the x-axis. So Fx is equal to m into ax. What is Fx? Force along x-axis is mg sin theta is equal to mass into acceleration along x-axis. So ax comes out to be g sin theta. Over here we see that is action comes out to be independent of mass. It means if its acceleration is at this particular angle is 2 meter per second square, so over here whether you put a body of mass 2 kg or 20 kg or 200 kg, the acceleration will remain same. Acceleration comes out to be independent of the mass of the body. So acceleration of this body this way is going to be g sin theta, provided the surfaces they are frictionless. If friction is there, this value will get altered. Now let's understand, if the value of theta is very small, that is almost equal to 0, if we have made it flat, that is we have converted this theta, this slope AB also, that is we have just made it flat, horizontal, then this theta comes out to be 0, and obviously the acceleration over here, is g sine 0 is equal to 0, because sine 0 degree is equal to 0. If we keep on increasing this angle, keep on increasing the angle, obviously sine 0 to 90 is continuously changing. And if we make this as at an angle of 90 degree, this block is over here. Now g sine theta, g sine, now angle with this, g sine 90, sine 90 is 1, that is it will be moving down, this will be accelerating down with the value of 9.81 meter per second square or 10 meter per second square, or with the value of g, it will start accelerating downwards. So as you increase the angle, there is a frictionless surface, as you keep on increasing the angle, this acceleration down the plane, it keeps on increasing and its value is g sine theta.